Okay, this is a scenario of a sporting event, and I'm just working out and calculating the pinpoints and the entry and exit of the scene of the sporting event and the makeups of it. So how it all came about, what the distraction or the interjection, and where everything changed and where it was confusing, where it was can't think of the word. Where it was changed. So we've got the tarps, 1, 2, 3, 4, 5. We've got the circle as in time. That represents time and degrees in the area of a circle. We've got the starting point here at 12 o'clock, 90 degrees. We've got 90 degrees, 3 o'clock where I was positioned. We've got 90 degrees at 6 o'clock where the subject A was and B, but more importantly subject A. And we've got here, we've got another point at point at 90 degrees at 9 o'clock, and that point correlates, is adjacent to that as well. So they're the points. Okay, so to starters, subject A was the focus point for me. So I had a adjacent point of focus and line, linear line to subject A. Okay, so the sporting event took place and everyone was at their stations and the events were going through. And somewhere along the way, I got lost in time and I didn't realise the time. I didn't realise the time on my phone or my watch. Sorry, my watch. And subject A moved from his position and casually walked across to my position within this vicinity at 90 degrees, and he removed a pin or a peg from there, causing this corner to blow up because it was windy, and walked back to his position at 90 degrees, 6 o'clock. Now, I was stunned and confused about why he came over in the first place, let alone why he removed the pin, because I was confused by this and I didn't realise the time or what it meant. So I'm just thinking, why did he come over and kneel down and pull the peg out? Anyway, so because that happened, I moved back from that station and moved back further down here to here. this had flown up to this linear line. And by the way, to add, I don't know the exact coordinates or the exact measurements of everything. I'm just doing it to my own understanding, my own ideas, and my own demonstration that was 100 centimeters or 1 meter by 1 meter. And that was the hypotenuse of this triangle of a equal triangle. I can't remember how you pronounce it. Equal-sided triangle. But it didn't go all the way at first. I noticed over time this did start to go all the way up, blow all the way up. This top started to blow all the way up to the other corner, to the adjacent corner. Anyway, this corner first, when it curled up, I wanted to find what the area of this triangle would be. I wanted to find the hypotenuse and the sides of what that measurements would be. So if each side is 100 centimeters, then to find the hypotenuse, you'd have to do c squared equals a squared plus b squared. C squared equals a squared. 100 times 100 equals 1,000. And then you do that 2 times plus 1,000 equals 2,000 squared. And then I did it wrong there, so I'm not sure what it is there now. But I came up with 200, but it's wrong because I'm not sure how to do that. But that's what I did. I did 200. So let's just say it was 200. Let's just say that hypotenuse was 200. If we go over here now to this one, and we see that I left this position here and I moved over to this position, past this position, to this, passing this top, I noticed that this corner from this top was removed and was flapping over. There were still contestants on there, so I'm thinking to myself, well, they must be moving because he only removed one from here. He didn't remove every single corner off, just the one. So that was the distraction and confusion. And then this became the second one. It was a very windy day, let me add, so this was flapping around. So I went to the toilet, to this position, and then came back past here and noticed this one had been removed. This corner had been removed, creating this plane. Because those all curled up. Okay, and everyone wasn't on there. So I wanted to work out what the area of this plane would be. So if the hypotenuse was, if this is 100, if the hypotenuse is 200, right, then, and it's at 90 degrees triangle, I first worked out this was 45, this would be 45, this would be 45, and then I'd be able to work out this hypotenuse would be 180. Okay, this is not good maths. I'm not very smart. This is just for me to practice listening and working out things on my own. So it's not correct. It's all wrong, but I'm just trying to work out how the tools are used to find out stuff and work out maths. So it's all wrong probably, but I don't care. This is just for me. Anyway, so that hypotenuse of that triangle, that equal triangle, isosceles, sorry, it was equal. Oh, maybe it's equal now. Anyway, we'll just say it's not. We'll just say that line is longer than those lines and is at 180. I think I got that wrong too. Anyway, I have to go over it. It's very wishy-washy. I'm not very good at maths. So then, how do we find the area of this plane? We cut a line here and make a shape here. So we've got one side here becomes 180. And then we've got one side here to work out. So if that is 200, I don't know what I did. I said if that, this is just for me. We're just using measurements and stuff, but to work it out. If that is 200 down there, that linear line, I've done it wrong. I've done it wrong. Anyway, we'll just keep going. If that was 200, then if we were to minus, I don't know. Doesn't matter. I'm going to end it.